Hi guys, welcome to today's lesson on GeoGebra. So today we want to look at transformation. And with transformations, we have two types of transformation. We have the rigid motion and non-rigid motion. So today we want to look at rigid motion. And then with rigid motion, it's any transformation that does not alter the distances or the angles when that particular object is being transformed. So today we're going to look at rotation about a point and then reflection, look at reflection about a line and then translation by a vector. So to start, we want to change a labeling to point only. Okay, that's okay. So we're going to create our object and then we want to create this object with points. And join the point to the polygon tool. Now we have our five-sided figure, that's a pentagon. Now that we have this, we're going to look for so in order to rotate about a point, you must have the center of rotation. This center of rotation is the point at which the object will rotate. And the other thing we must also have is the angle of rotation. So now let's create our center of rotation with a point. Now I want our center of rotation being our origin. Now we have that. The next thing I want to do is to create circles. And in these circles, we'll have the center, if that is the origin, and we'll pass through the points of the polygon. So that's A, B, C, D, and E. What I would want to use the circles to show that whenever the object is being rotated, it moves in the same orbit as the rotated object. So let's get into creating our circle. So we're going into the input field, circle. We are creating the circle with 2 points, point and a point. So circle FA. The next one is going to be circle with a point and a point. It's going to pass through B. The circumference will touch B and then the center of F. So we'll do for all 5 sides. Point and a point. F, now C. Circle. F. So the next one is C. Circle. Point and a point. The next one is FD. Enter. Now the next one is going to be FE. Circle. Now we have the circles. We can also make this, we can change the properties. That's color this circle and then do something about color this object and do something about our circles. Object properties. We need to look at the color. Let's choose this color. It's a positive. Now we want to look at the circles. We don't need this point. This error is happening because it's not in the move to. So now I have it in the move to. Let's go ahead and edit our circles. So object properties. We want it to have deep colors. Okay. So in the style, let's look for the style. You can do same for all the 5 circles. You do last for the last one. So we are going to create a checkbox, and then this checkbox will help us show or hide our circles, and then we'll hide it when we don't need it, and show it when we actually need it. So go to checkbox. Now our caption is going to be show or hide circles. So we're hiding circle F, circle G, circle H, circle K, circle P, and circle Q. Right. So now we have our checkbox. Now, the next thing we want to do is to create a slider, and then this slider will serve as our angle of rotation. So let's create a slider. We can name our slider R for rotation. We want our slider being an angle. So R. It's having a minimum of 0 degrees and 360 degrees, increment of 1, which is fine. So, okay. Now that we have our slider, we want to rotate object polygon. So now let's do that. So now we do that in the input field, we type H equals. So now H becomes our new object when it's being our new object. And then this new object is formed when object, that's polygon, is being rotated. So object equals rotate. Object in angle. Our object is polygon. Polygon. And our angle of rotation now becomes our R. So now that we have this, we'd want to create a line segment that is going to touch F and A, so that as the object is moving, F and A, and then F and A prime. So as the object is moving, we can see the angle without having to look at the slider. Okay, so let's do that. Line segment. We're going to choose the line segment on the polygon on the toolbar. So F and A, and then A prime. The next thing I'm going to do is go to the angle side, angle A, F, A prime. So now we have it at 100 degrees. So we were saying that anytime an object is being rotated, the distances are preserved. Okay, the distances are preserved in the sense that the distance from A to B, the same distance as from A prime to B prime. So let's see if that is true. So the distance from A to B is C, that is small c, that is 2.33. And we're going to look for C prime, also get C that is 2.33. Now, we also said that the angle is being preserved, okay? In the sense that the angles formed between these points in the polygon is the same angles that you get in the rotated object. So let's check for that. And yes. So now compare, realize that the angle formed at A is 77.47 degrees, and then the angle formed at A prime is also 77.46. If you check for C prime, realize that C prime is also equal to C. So now we've established that the angles are being preserved when we rotate, and then the length are also being preserved. Now the next thing I want to do is to go ahead and so now that we've seen that we can deactivate the angles, okay? You're not using them now. So we can deactivate them. All the angles. Now, let's edit the rotated object so that you see the difference. Let's put that and move it to. The next thing I want to do is look for age. Okay. Object properties, and then choose a different color for that. So now we have style. We go back to color. Let's choose a bright color. We have this. Good. Perfect. So I'm going to animate this slider. I'm going to animate this slider. Animation will be on. and increase the speed. Let me increase the speed to 5. So we can see that at 360, the rotated object falls on the original object. And then we can also see that at 90, the rotated object is in the fourth quadrant. And as 230, right now, this rotation is going counterclockwise or anticlockwise. So at 90 degrees, you realize that at 90 degrees counterclockwise, the object is on the fourth quadrant. At 180 degrees counterclockwise, the object is in the third quadrant. And at 270 degrees counterclockwise, the object is in the second quadrant. And then when the object is rotated 360, the same as it's rotating 0 degrees, so it's still in the first quadrant. Okay. Now, the other thing I want to see and show you is that so whenever it's being rotated, the x and y axis, something happens to it. Okay. So now let's see for the a component. Now we have our a prime to be negative 2.77, and the y coordinate is 2.3. So let's see what we had for a. So we realize that our a was 2, 3. Let's see, we have this to be 90 degrees. So at 90 degrees, you realize that the x coordinate in the first quadrant is x and y, and then both x and y are positive. But then when it moves to the fourth quadrant, it now becomes, so let's do that, let's label that with text. So I'm saying in the first quadrant, you have a x and y. Being positive. Now, when we come to the fourth quadrant, what do we see? We realize that our x coordinate in A was 2, 3, and then our x coordinate in A prime was minus 3, 2. So we realize that there's a flip. Our x now becomes our y, and our y becomes our x. Then our y coordinate is being negated. So we have negative y, negative x. Sorry, negative y, x. Our x coordinate is positive. So now let's check what happens when it's at 180. 180 clockwise and counterclockwise rotation. At 180, you realize that right now we have negative 2, 3, negative 2 and negative 3 for A prime, and we have A to be 2 and 3. You realize that right now there's a negation of both x and y, and then the new form becomes negative. The new form becomes negative x, negative y. Negative x, negative y. So this is for rotation in 90 degrees and 180, 270 and the like. So this is what I want you to see. Now continue my animation again. So you are seeing that it's moving in the same orbit. The A component is in the same orbit as the A prime. Nothing changes about that.